Okey-doke. Last video, you'll be pleased to hear. Okay, we're going to talk about where the numbers come from in SN1 and SN2. Okay, so in an SN2 mechanism, the rate of this reaction depends on both the halogenoalkane, which I'm going to use Rx as the notation for, and the nucleophile. Okay, because remember in the first step, the nucleophile comes in and attacks the halogenoalkane. So if I was to write a rate equation for this, I would say the rate is equal to the rate constant. It's going to be depending on the concentration of the halogenoalkane, and it's also going to be depending on that nucleophile. Okay, so what you can see is that there are two species in the rate equation, hence the number 2, and we can say that this is biomolecular, just bimolecular, meaning two species are responsible for that rate. Okay, if I change this now to talk about an SN1, the rate of this reaction is only dependent on that very first step, which is the slow step, where you're simply waiting for the halogen to break. So this time, the concentration of the nucleophile does not matter at all. You can have absolutely loads of nucleophile in there, but it's not going to make a difference to the rate because we're waiting for this first step, the halogen breaking off. Okay, so this time the rate is simply going to be the rate is equal to the rate constant, and it depends on the concentration of the halogenoalkane and nothing else. One species in the rate equation, one over here, and this time we can describe it as a unimolecular reaction because it only depends on one species. Okay, I hope that's all a little bit clearer to you now. Please do practice these mechanisms. Try with all the different nucleophiles, so cyanides and ammonia. There's lots of questions available in the files for you to have a go at. And as always, any questions, please just ask and we'll go through it again. Okay.